not every day that we have on the podcast someone deep into biotechnology and data and AI. So maybe where we could start so that our audience can best understand context is to tell us about where Bioptimus sits within this overall landscape of biotech, AI, and data.
Yeah, sure. Thanks for the question. So I would say Bioptimus, if you had to simplify a bit, positions itself at the level of building a horizontal platform, a bit like you would say an OpenAI builds GPT or Anthropic builds Cause. They build a technology that then is used by many users, many companies to build useful use cases. And so Bioptimus is doing the same, but instead of training AI, LLMs, to speak the human language, it builds an AI to speak the biology language. So think of it as learning from data to understand biology. This is encapsulated into a software, so an AI system that then we sell to customers, so pharma companies, biotech companies, medical labs, that borrow it in order to build use cases. And use cases go from diagnostics systems, so to identify patients that would respond to a treatment or patients with a disease, up to drug discovery, like identifying what would be a good treatment for a given disease.
So is it the case that anyone in, say, the pharma field could tap into one of your models and simply type a question, obviously relevant to the work they were doing, and they would get an answer?
I think we're not there yet because we're still, overall the field is less advanced, I would say, that other applications, in particular in the capacity to interact in human language and correctly answer questions. Where we are today, and I would say the field overall is about still building the foundations, meaning still training AI systems that start learning how biology works. Like that, I mean, it's about, okay, you show to your system millions or billions of images of cells or tissues or cancer samples. And after showing billions of them, the system learns by itself subtle differences between cancers, between tissues, between cells, in order to be able then to in silico predict, for example, how a patient would respond to a treatment. So today we don't have the system ready yet. It's it's being built, but eventually it will come. And I think probably we will not have a generic system that can answer all questions. At least in the foreseeable future, we have a system that still needs to be what's called fine-tuned, so specialized as soon as the user has a specific question. So to be a bit concrete, we have systems today, for example, that are on the market that we release that are open source and commercial versions that have been trained to read specific types of images used in cancer diagnosis. It's called pathology images. And so what our system does is you show it an image. Suppose you have a patient, you take a biopsy to check if there is cancer, and it leads to an image. So you show the image to our system, and our system today can capture the content of the image into numbers, right? It's called the encoding of the image. But then if you want to ask a question like, okay, can you tell me this patient, what's the subtype of the disease or what's the genetic abnormality, etc., our system does not answer it yet, but it can be trained to do so. And so this is the post-training that we do every day to be able to answer specific questions.
The I guess interpreting of the image relies on a lot of prior data, I assume. What data do you tap into, and is this kind of part of your proprietary technology, is that you do have access to these libraries of data?
Yes, absolutely. That's a great point. So yes, short answer is yes. We do have access to proprietary data, and this is needed. So Maybe to give some context, I mean, everyone hears about LLMs and companies, training LLM on lots of data. When we talk of LLMs, most of the big models today are trained on the same data, which is basically all the web, right? So you go to the web, you have text, you have images. So you can download it. Some companies have specific data, but overall it's common resource, right? Now, if you want to do a similar approach, but train your system not on the web, but on genomes, on patient records, on images, then there is no web anymore, right? The data is, I mean, depending on the modality, the data is in hospitals, is in companies, is in research centers, etc. And so it's harder to access the data. And BioOptimus started with the clear vision that we are the ones building the model, but to get the data, we do partnerships. And so we started very quickly with partnerships. Actually, we started with a specific partnership with a company named Owkin that has built the world's largest atlas of cancer. So it's several thousands of patients with very deep characterization. So not only images, but sequencing, etc., DNA. And this is a proprietary data set, but that Bioptimus has access to. And on top of that, Bioptimus has made deals, so with a variety of labs, companies, to be able to access data to train the model. So it's a long answer to say, yes, data is key and it's hard to get, and it's fully part of Bioptimus strategy to have a diversified source of data through partnerships. We are also now starting data generation. So this is, again, through partnerships with hospitals and other companies that we fund data generation to increase even more the amount and quality of data we train for.
So, fast forwarding to a time where, all the pharma companies that, are in drug development, all the biotech companies need your platform. They would not be able to, or perhaps you're the leading competitor in this space, they would want to use BioOptimus because they know when they type in or when they start to use your platform, you would give them the most sophisticated output, meaning you're tapping into the largest libraries of data and giving them the most accurate and advanced responses. Is that how you think about it? Like, it'd be difficult for a competitor to replicate what you're doing because of two reasons. The data that you have access to, as well as that you're way ahead in terms of having trained your models.
Yeah, so yes, and there is also something else. So coming back to what you say, so yes, we are playing, there are competitors, but we like, as I said, we have released already some products, which on it's a bit like LLMs, there are tons of benchmarks to compare models, etc. There are quite a few benchmarks where our models are clearly leading, like from an image, can you predict patient characteristics, or can you predict the presence of proteins? We are very, very strong on that. So that's one reason why a customer will use our model, because it's the best in class. Now, the second feature, which is coming, is that we are building something that does not exist, which is a foundation model that can read not a single modality, like not only images or not only genomes, but that can have a global view of all of the data. And so it has new capabilities that don't exist today in any other competitors, which is, for example, you give me the image of a patient, and our model will be able to predict the activity of the genes or the evolution of the trajectory of the patients subject to different scenarios, etc. So I would say these are things, of course, we need to build them, but this is at the core of Bioptimus strategy, to not focus on just an AI system for image or just an AI system to discuss with the doctor, but a set of new capabilities that emerge when you train a system from diversified data, not only in terms of different patients, but different modalities of input, images, genomes, spatial proteomics, etc. And so this is this will be the most differentiating factor in the future.
And then do you foresee others building on top of your model? So like in essence, a new company could be started that's based on BioOptimus as the
Yeah,
foundation layer.
absolutely. Actually, this is, I think it's very clear that the market is converging to, let's say, companies optimizing what they're good at. So I think today, you still have, many companies trying to train foundation models as soon as they have data, but very quickly they realize they need more data, then it's expensive, etc. And so it's easier to buy than to build at some point. So clearly, we position ourselves as the builders of the foundation model, and for many companies, it will be easy to buy our models in order to build something else on top of it. Just like for LLMs, right? You have the OpenAI, Anthropic, Mistral, etc., that build these LLMs, and then you have zillions of companies that pay the API in order to build services, use cases on top of it. So I could expect many companies, and including new companies, to build fancy things on top of the models we build. What we build is, let's say, the computational world model of biology, meaning it's a system that can read data, that can simulate data, that can predict data, and then companies will build on top of it. Yes.